Everyone, myself Somiya SP, Assistant Professor, Department of Civil Engineering. Today, it's the Module 2 from Design of Hydraulic Structures. In Module 2, it deals with two theory, that is Kennedy's theory and Wilsey's theory. In this presentation, I'm discussing about the Kennedy's theory, its design procedure, and a problem based on that. Kennedy's theory. Actually, Kennedy conducted an experiment in Upper Bari Doab Canal, which is situated in Punjab. He states that the silt carried by flowing water in a channel is kept in suspension by the vertical component of eddy current, which is formed over the entire bed width of the channel, and suspended silt rises up gently towards the surface. And he follows some assumptions, that is, the eddy current is developed due to the roughness of the bed. Second one is quality of silt depends upon to the bed width, and it is only applicable to those channels having same grade as in Upper Bari Doab Canal. And he established an idea about the critical velocity that is expressed as V0, which will make a channel free from silting and scoring. That is V0 is equal to CD raised to N, where C is equal to a constant which is 0.546 and N is equal to 0.64. Therefore, V0 will be written as V0 equal to 0.54 D raised to 0.64. This V0 was affected by the grade of silt. So he introduced another factor, that is the M, that is critical velocity ratio, which is expressed as CVR, that is critical velocity for the area divided by critical velocity for Upper Bari Doab Canal. So the equation critical velocity V0 will be equal to V0 is equal to 0.54 into M into D raised to 0.64. Next, he uses the Cutter's equation for finding out the mean velocity, that is V, that is equal to 23 plus 1 by N plus 0.00155 divided by S, the whole divided by 1 plus 23 plus 0.00155 divided by S into N by R into root RS, that is V is equal to C into root. Next, we move on to the design procedure of Kennedy's theory. By Kennedy's theory, he has explained in two cases with given values differences. That is, in first case, discharge Q, Manning's coefficient N, critical velocity ratio M, and the slope is given. That is Q, N, M, and S are given. So first, we assume a trial value for depth of a channel in meters. Next, we can find out the critical velocity, where V0 is equal to 0.54 m d raised to 0.64. That is, m is given and d is an assumed value. Next, we can find out the area from the continuity equation, that is, area is equal to Q by V0. Q is the given condition and V0 is the critical velocity. So we substitute the values and we find out the area of the channel. Now knowing area and depth, we can calculate the bed width from the equation area is equal to BD plus D square by 2. Next, we have to find out the perimeter and finally we have to find out the hydraulic mean depth, where perimeter is equal to B plus D root 5 and hydraulic mean depth is area by wetted perimeter. And we find out the actual mean velocity of flow V from Cutter's equation, that is V is equal to 23 plus 1 by N plus 0.00155 divided by S, the whole divided by 1 plus 23 plus 0.00155 divided by S into N by root R into root RS. Next, if the value V is equal to V0, assumed depth is correct, or else we have to repeat the calculation by assuming the new depth. Okay. So we first assume the trial value d in meters, then we have to find out the critical velocity V0, then we find out the area from the continuity equation. Next, from area and the depth, we can find out the bed width of the channel. Then we move on to the perimeter and then finally to hydraulic mean depth. Then we have to find out the actual mean velocity by the Kutter's equation. On comparing the critical mean velocity V0 and actual mean velocity V, if it is equal, then the depth correct. That assumed will be right. Otherwise, we have to change out the depth and we have to repeat the same procedure from the beginning. Okay. Next procedure is the case 2. That is, given condition is discharge, Manning's N, M and B by D ratio. In the previous case, it was S. Slope was given. Here, B by D ratio is given. That is, B by D is equal to Y. First, we have to find out the area in terms of D. That is, area equation is BD plus D square by 2. Since B by D ratio is given, we can substitute D equals to dy. So, area will be equal to YD into D plus D square by 2, or D square will be taken out, that is D square into Y plus 0.5. Then we can substitute the value of V0 and A in continuity equation, that is Q is equal to V0 into A. Substitute V0 equals 0.54 m d raised to 0.64 and area as d square into y plus 0.5. So on simplifying the equation, we get as 0.55 m into y plus 0.5 d raised to 2.64. Then you can find out the depth, that is d is equal to q by 0.55 m into y plus 0.5 the whole raised to 1 by 2.64. Since discharge is given and y will be given. Okay. Next, knowing depth and we can find out d bed width and the r. That is b is equal to dy. So from the above equation, we get the depth. So depth into the ratio will give the bed width, and we can find out the hydraulic mean depth R is equal to area by measured perimeter. That is substituting BD plus D square by 2 divided by B plus D root 5. Next we move on to the critical velocity V0, that is 0.54 into m d raised to 0.64. Knowing critical velocity and R, we determine the slope from Kutter's equation by substituting actual mean velocity V as V0. Hence, V0 equals to 23 plus 1 by n plus 0.00155 divided by s. That is the unknown factor, and all the other terms are known. So, by trial and error method, we can find out the slope. Once again, we have to find out first area in terms of depth because B by D ratio is given. Next, you have to substitute the value of V0 and A in continuity equation. By knowing discharge M, Y, we can find out the depth D. By knowing the D, we can calculate the bed width B and the hydraulic mean depth. Next, we can find out the critical velocity V0 and then final to the slope by Kutter's equation. That the equation is solved by trial and error method. The question, design an irrigation channel on Kennedy's theory to carry a discharge of 45 kmx, take n equals 0.0225 and m equals 1.05 and channel bed slope is 1 in 5000. That is, discharge is given as 45, n is given as 0.0225, m is given as 1.05 and channel bed slope s is given as 1 in 5000. So you have to first know about the which cases is given, that is case 1 or case 2. Since discharge n, m and s is given, it is the case 1. Instead of slope, if it was b by d ratio, then it will become as case 2. So we move on to the first step, that is assume a trial value of d in meters. That is, we are assuming d equal to 2 meters. Next, we find out the critical velocity from the equation V0 is equal to 0.54 md raised to 0.64. Hence, we substitute the m value as 1.05 and depth as the assumed value, that is a 2 meter. We get the answer V0 equals to 0.899 meter per second. Next, we find out area from the continuity equation, that is A is equal to Q by V0, where Q is given in the question as 45 and V0 just we find out 0.899. On substituting the values, we get as 50 meters square as area. Now knowing area and depth, we calculate the bed width from the equation. Area is equal to BD plus D square by 2. Hence, we get bed width as 24 centimeter. Next, we find out the perimeter and hydraulic mean depth from the equation. Perimeter is equal to B plus D root 5 as 28.47 meter and hydraulic mean depth R as 1.75 meter. Next, we find out the actual mean velocity of the flow V from the Cutter's equation as 0.925 meter per second. Now, we have to check whether V is equal to V0 or critical velocity will be equal to actual mean velocity. If it is equal, we assumed depth is right, or else we have to repeat the procedure by assuming new depth. Since velocity is 0.925 and critical velocity is 0.899, so actual mean velocity is greater than critical mean velocity, so we have to increase the depth. So we increase the depth as to 0.1 meter. Hence, by repeating the procedure, we get critical velocity as 0.911 and actual velocity as 0.92 meter per second. On comparing that, similarly, nearly equal V0 and V. Hence, we stop the calculation. That is V0 equal to V. Okay.